Hello everyone, today we will learn about the measurable function from measure theory. So if f is a real valued function which is defined on a measurable set E, f is said to be Lebesgue measurable set for every alpha belonging to R real numbers, then the set x belongs to E such that f of x is greater than alpha. Let us prove one theorem which states if f is a extended real valued function whose domain E is a measurable set, then the following statements are equivalent. So the statements are as follows, where first we have f of x is greater than alpha. We have to show f of x is greater or equal to alpha, f of x is less than alpha, f of x is less than or equal to alpha. So this can also be written as E of f greater than alpha. So in order to prove this, we will prove first 1 implies 4. So how is this possible? So if we have f of x greater than alpha, x belonging to E such that f of x greater than alpha. So what is the complement of greater than? Complement of greater than is nothing but less than or equal to, correct? Complement of greater than is nothing but less than or equal to. So this will be f of x less than or equal to alpha. So we can write x belonging to E such that f of x is less than or equal to alpha. If we take the complement of greater than, we get it is less than or equal to. So I have written here. So let f be a measurable function, then by definition we know for every alpha belonging to R such that x belonging to E, where f of x is greater than alpha, which is by definition. So this which is a measurable set. So this implies that x belonging to E such that f of x is less than or equal to alpha. So we know from a theorem, if A is measurable, then A dash its complement is also measurable. So 1 implies 4. Similarly, 4 will imply 1. 4 will imply 1. That is the complement of less than or equal to. That is f of x less than or equal to alpha's complement will be f of x greater than alpha. So same thing we have done here. So if less than or equal to alpha is measurable, then greater than alpha is also measurable. Now we will, in a similar way, we will prove that less than complement will be greater than or equal to. That is 3 implies 2 and 2 implies 3. So what is 3? 3 is f of x less than alpha, correct? So it is x belonging to E such that f of x is less than alpha. So what is the complement of less than? It is greater than or equal to. So we can write f of x is greater than or equal to. So if f of x belonging to E, f of x less than alpha is Lebesgue measurable, then its complement is also Lebesgue measurable. Similarly, we can write here also. That is, if x belonging to E such that f of x is greater than or equal to alpha, what will be the complement of greater than or equal to alpha? It will be greater than or equal to will be less than. So we can say 2 implies 3. I have written here. So x belongs to E such that f of x is greater than or equal to alpha implies f of x is less than alpha. If this is measurable, this is also measurable. 3 implies 2, that is less than alpha. If f of x less than alpha is measurable, then f of x greater than or equal to alpha is measurable. Now we will see how greater than alpha implies greater than or equal to alpha. So what I have taken here, let f be a measurable function. Since x belongs to E, f of x is greater than alpha. This is nothing but intersection of n from 1 to infinity x belonging to E such that f of x is greater than alpha minus 1 by n. So you can take an example. If you take alpha as 5 and if you give different values for n, like for here I have done. So 5 minus 1 by 1 is 4. 5 minus half will be 4.5. 5 minus 1 by 3 will be 4.6. So all this intersection, so all these are nearing to 4. All these are nearing to 5. So greater than alpha can be written as greater than alpha minus 1 by n. So for any set on this right hand side, this is Lebesgue measurable. So we know countable intersection of measurable set is measurable. Hence we can say f of x greater than alpha is also measurable. In a same way I have done for 2 implies 1. 2 implies 1 says f of x greater than or equal to alpha. It should imply greater than alpha. So what I have done is, I have taken alpha plus 1 by n. If you take a similar example and you take union. So if you take alpha as 5, 5 plus 1 by n, give values for n as 1, 2, 3 and you will see here I have got 6, 5.5, 5.3, 5.25 and so on. So union of all this will be 5 only. So this is nothing but union, countable union of measurable set is measurable. So I can say f of x greater than alpha is also measurable. Thank you.